So we're going to be working on topic 1, question letter A. First part of it says write an equation for the formation of zinc iodide from zinc and iodine. So our reactants here are zinc and iodine. And our product is zinc iodide. So zinc is not on our diatomic list, not part of Brinkelhoff, so it is just zinc. Iodine is part of Brinkelhoff, so the formula is I2. And in writing a formula for zinc iodide, we need to remember that zinc on the always list for ions is positive 2, and iodine is on the always list as -1. So a good formula between those is ZnI2. And there we have our balanced equation. Then I'm moving into part B. 100 grams of zinc is allowed to react with 100 grams of iodine, producing zinc iodide. Calculate the amount in moles of zinc and iodine, and hence determine which reactant is in excess. So I'm going to start with the zinc. 100 grams of zinc. I'm going to put that unit in the bottom of the first step. And I'm going to look up on the periodic table, and it's 65.38 grams. So I have got 1.53 moles of zinc. Then I'm going to do the same process with iodine, remembering that it's I2. When I look up on the periodic table, I get 253.8 grams per mole for I2, so I've got 0.394 moles of I2. I look back to the question, which reactant is in excess? The limiting is the lower amount, the excess is the higher amount, therefore zinc is in excess. Moving into part C, calculate the mass of zinc iodide that will be produced. It's going to be the amount that's produced from my limiting reagent, which is my iodine. So I'm going to start using the moles of iodine that I had. And then I'm going to use the balanced equation to go from moles of iodine to moles of zinc iodide, which is 1 to 1 from the balanced equation up here. And then I'm going to say 1 mole of zinc iodide from the periodic table, 319.18 grams. I just added up the individual values. And that, after I put it into my calculator, multiplying by the top, dividing by the bottom, gives me 125.8 grams of zinc iodide produced.